is layer 2 scalability solution on top of Bitcoin. And some of the other topics we will cover are DeFi stands for decentralized finance, and privacy and scalability are again some interesting research topics in the Bitcoin industry. So let's look at the introduction to layer 2, Lightning Network, and developing on top of layer 2. So right now, if you do a Bitcoin transaction, transactions aren't instant, and micropayments would actually work. So if say you wanted to do a transaction of $1 or 1 cent or something like that, you won't do it. It's like if you are going to pay $1 to do a transaction of 1 cent, that doesn't make sense, right? And the transaction fees, Bitcoin transaction fees, is around $1 or $2, $3. And during the hype of 2017, when Bitcoin's price had risen to almost $20,000, um, the price of doing one transaction had gone up to $50, and of doing transactions had gone to $50. Yeah, I can just show the graph of Bitcoin fees as over time. But it's like the block size of Bitcoin is only 1 MB, and there's certain limit of how many transactions can go in that block. And because each transaction takes certain amount of data, and price is defined by the market, right? If someone is paying miner $1 for a transaction and someone is paying $10, then the miner will go ahead with the person who is paying $10, right? He or she will include that transaction in the market. So this is like the chart of Bitcoin transaction fee. So you might see, okay, at this point in 2009, it was almost zero, very, very less. Then started increasing. Then, and this value is in US dollars. So in around 2018 and time frame, it went to 53 US dollars. Right now, it's around $3, which is quite high, right? Um, if it's low, if you want to do a global transaction, if you say want to send money outside, you can send for $3, and the Bitcoin network doesn't charge commission or something like that. Like, say, if you wanted to send, people have sent like $1 billion or around that in Bitcoin for like $2 or $3, right? Moving $1 billion in a bank for $2 or $3 is something which is unimaginable. But in Bitcoin, people have done it. But if say you want to only send $10, you want to buy a cup of coffee for Starbucks, maybe doesn't. So and as Bitcoin gains more popularity, this value is only going to increase. And just looking at the numbers, 1 MB block, we have 1 MB block that gets mined in every 10 minutes or so. We have like seven. If you look at, like, say, each transaction has 250 bytes, you'll get around 7 transactions per second that Bitcoin network can accommodate. And there are 220 million transactions per year. I think this number would be quite high now, given we have like, and yeah, so uh, we have, if no, and this is not enough. So 220 million transactions is for the whole Bitcoin network for the entire year, and this is not enough for a city, and definitely not for the world. And 1 billion transactions per day, if Bitcoin had to do that, then we needed to have a block size of 1.6 gigabytes. So 1.6 gigabytes that would get mined after every 10 minutes. Then we'll be able to do, 1 billion transactions per day. And maybe, yeah, and then that too, that might be, say, I don't know the exact numbers, but um, this would be sufficient to an extent. And okay, so this was if we have 1 billion transactions per day. If we have like 7 billion people in the world doing 2 blockchain transactions per day, that's just an average. Like, say, if when the economy opens up after coronavirus, I think all of us use Paytm and Zomato and all these things. For me personally, I might do like 20 transactions per day. So on average, if we take 2 transactions for 7 billion people, you need 24 gigabyte blocks for per 10 minutes, right? And bigger. So why can't we have bigger blocks, right? Why can't we have a Bitcoin network that runs these big 24 gigabyte blocks? The reason is centralization, right? If, if we have 24 gigabyte blocks that get mined every 10 minutes, like we need everyone would this 24 gigabytes of data needs to be combined to the network, right? Uh, for that really fast internet connection, and we need really powerful computers. So what that would mean is, like, I won't be able to run a node on my laptop. Now, right now I can run a node on laptop. It might not be mining node, it might not actually do add blocks to the blockchain, because that for that you need a lot of computation power. But I can in fact just listen to the blockchain. I can listen to what transactions other people are doing, what are the blocks that are getting added. But if the size of the blocks increases to 24 gigabits, then I just won't be able to participate in the network. What we'll have is, we'll have, like, say, two companies that will be running the blockchain, and only they'll be able to see the transactions that are happening in the network. And I think that's what essentially banks are doing already. So that doesn't solve much problem. So we basically, bigger blocks means centralization. And so what are the scalability solutions, right? We already have the SQL database model that scales to this scale. And yeah, banks and Facebook and all these social media companies, all the internet is built using the database model. But that's centralized, right? We have one company that is running those databases, although it's still centralized. Um, but we don't want that. What are the scalability solutions? One is sidechain. So basically, I'll walk through the scalability solutions in depth, but here I'm mostly looking at scalability solutions that teams are working on in the Bitcoin space, not in the overall blockchain space. Like, not I'm not talking about the scalability solutions like, say, that's teams are working in Ethereum. Just focusing on Bitcoin here. And sidechain is one solution. You can read more about it. It's basically, you run a parallel chain in which it's sort of like a permission chain, and you have some validators that are doing the transactions, and you can um, move funds from your main blockchain to the sidechain and vice versa. But again, it's not that ideal, because the sidechain is it's sort of centralized, and you don't know what yeah, it's not recommended. Because sidechains, you'll have 4 or 5 people who are basically running nodes for that, and they can collude among themselves, um, and stuff like that. So again, it comes back to the centralization problem. um, and then we come to payment channels, right? So payment channels is an interesting topic, and that's what Lightning Network is. In fact, it's a special payment channel to an extent. And payment channels are beneficial when people pay each other many times, right? Like, say, if we have I have I go to Starbucks every day, or I go to Starbucks regularly. I open a payment channel with them, and I know that I do transactions with them every day. So it makes sense for me to open a payment channel with them, and then we can do off-chain transactions. And I'm just giving an overview. We'll just look at how a payment channel works and stuff like that just about later on. Yeah, so some interesting documentation on Lightning would be reading the LND documentation. So LND Lightning Network has various implementations. So there's this company called Lightning Labs, which is backed by Jack Dorsey from Twitter and great VCs and stuff. And they have their implementation called LND. There's also C Lightning is another implementation of Lightning networks that is done by a company called Blockstream. Um, there's also another, but the most used one is LND by the Lightning Labs team, and an interesting book Lightning. I think it's still people are still working on it. It's not finished yet, but you can check that out. So for payment channels, the main one interesting concept for payment channels is hash contracts, and hashed specifically hash time lock contracts, right? And so this forms like the core of the payment channel concept or topic. And the idea is, say, if Alice is this is Alice, this is Bob, this is Charlie, and they Alice has a payment channel with Bob, and Bob has a payment channel with Charlie, and Alice wants to buy something from Charlie for 1,000 satoshis, right? And is basically the smallest unit of a Bitcoin. So 100 million Satoshi equals one Bitcoin. So Satoshi is something like, you can say, paisa. Like one paisa is the smallest unit of a rupee, and 100 paisa equal to one rupee. But in Bitcoin, we have 100 million Satoshi equal to one rupee. So equal to one Bitcoin. So you don't need to buy one Bitcoin. If people say, some people think, okay, you one Bitcoin, you can buy 0.00001 Bitcoin. You can divide a Bitcoin. The smallest unit you can buy is one Satoshi, which is equal to 10 to the power minus 8 Bitcoin. So yeah. Now, so let's look at this example. Okay, so we have this scenario: Alice, Bob, and Charlie. And Alice wants to pay Charlie, and we have this payment channel. So just keep in mind that we have this concept called payment channel, right? Just don't no need to think about how it's working. Just have it this in mind. And we have Alice that wants to pay Charlie, and we have Bob in between. So what how would they how would Alice pay Charlie with Bob being the intermediary, right? So what happens is Charlie creates a random number x, and he hashes that to get h of x. And via a secure non-blockchain channel, Charlie sends h of x to Alice. Maybe through a wallet, like a wallet or something. He sends h of x to Alice. Now, Alice uh, what Alice does is Alice sends 1,000 satoshis and h of x to, and the condition is Bob gets to know x, only then he'll be able to redeem 1,000 satoshis. Okay, and now what happens is Bob, um, yeah, and just to clarify, the condition here is if Bob tells Alice x, only then he'll be able to redeem the 1,000 satoshis. Now in Charlie, what happens is, now what Bob 1,000 Satoshi and h of x, and he tells Charlie, okay, if you tell me x, and Charlie will be able to get 1,000 Satoshi from Bob only if Bob tells Charlie x. Only if Charlie tells Bob x. So okay, so this might get a bit confusing, but let's understand. So we have this system, right? Alice, Bob, and Charlie, and Alice wants to pay Charlie, but Alice doesn't have the payment channel directly with Charlie. Alice has a payment channel with Bob, and Bob has a payment channel with Charlie. And this is what happened. Charlie created h of x and x, gave Alice h of x. Alice gave 1,000 and h of x to Bob, and 1,000 Satoshi will be recoverable by Bob only if he tells x to Alice. Similarly, Charlie would be able to. Similarly, Bob will be able to recover if Bob gets X. Then only he'll be able to send Charlie 1,000 satoshis. So what essentially ends up happening is Charlie tells Bob X. Bob is able to get uh, tells Charlie X, and Bob then sends Charlie 1,000 Satoshi, and then Bob tells say Alice X, and then Alice sends him 1,000 Satoshis. So essentially, 1,000 Satoshis gets transferred from Alice to Charlie, with Bob being the middleman. Yeah. So yeah, this is something you can think more about it. I think it's a simple concept using hash functions. Um, this is another illustration of that. Uh, this is how exactly it happens. We have R, H, and to that, and essentially everything is no one is like talking in English and something like that. Everyone is communicating through signatures and sending data through signatures. Um, yeah, so that's how it works. Okay, and what happens if Charlie or Carol, Charlie refuses to disclose X. Um, so now Charlie doesn't tell, if Charlie doesn't tell Bob X, then what would happen is Bob won't be able to recover funds from Alice, and the payment channel of Alice and Bob just gets stuck. Um, and if yeah, so and if her channel expires after Alice and Bob's, she might be able to steal funds by redeeming the hash lock. Um, yeah, and so the thing is that's why we introduced some time lock in this. So the concept is HTLCs, hash time lock contract, and there's like a time frame till which you can do these transactions. If no one signs and sends these messages to each other within that time frame, then uh, the payment channel, so as to speak, expires between the parties. Yeah. So yeah, that's how it works. You can look at this more. I just wanted to give an idea on how things work. So this essentially, so I'll just talk about the some overview of this more. So we have Lightning Network, right? So what Lightning Network is? It's essentially this HTTP type. It's a payment channel, and what happens is a payment channel. The idea behind Lightning Network is like say if there are so someone opened the payment channel, and opening of a payment channel is a blockchain transaction. So say there are 100 companies that are providing these payment channel type solutions, right? Like there are 100 Bobs in the world that have that are willing to open payment channels with other people. So like say there is a Bob in Chandigarh, there's a Bob in Delhi, there's a Bob in so now I would connect to my Bob in say a company called, say, I don't know, SBI, maybe say SBI, the bank runs a Lightning payment channel. I would send a blockchain transaction, and I will open a payment channel with them. And essentially, what you're doing when you're opening a payment channel is you are submitting some funds to that payment channel. You are, say, I submit one Bitcoin to that payment channel, and then you can always withdraw funds from that payment channel, but that funds get logged in on that payment channel till you withdraw them. So now what would happen is I would send say one Bitcoin to the SBI payment channel in Chandigarh. And if I have to send say funds to someone who is in New York and who has a payment channel open with say Wells and Fargo. Yeah, someone has a payment channel open with Goldman. So and Goldman Sachs. Yeah, can everyone please mute their mic? It's quite disturbing. Yeah. So if Yeah, so if SBI, if I SBI Chandigarh and New York, Goldman Sachs New York, if they also have a payment channel, right? So we have New York and SBI that have a payment channel, and this is me, and I have a relative that has a payment channel with SBI, and I have a relative payment channel with Goldman Sachs, then we can do these off-chain transactions. We can send money, and this is not happening on the blockchain. So when I opened a payment channel, that was a blockchain transaction. But when I'm sending these funds using the payment channel, then those are not blockchain transactions. That's just like happening off-chain. Although, since we are using signatures, you are signing your message using your private key, your say Bitcoin private key, so that shows that okay, this is you actually that is spending those funds, not a bank or payment channel company can't spend your funds as such. um, but yeah, so that's how it works. And so this system sort of is again infinitely scalable. So the only limitation is around opening payment channels. So everyone has to open a payment channel with someone. Once they open that payment channel with someone, and if that person is connected to almost every other major payment channel provider, you can send transactions off chain to people using this Lightning network. So that's Lightning network is this the network of these payment channels, essentially the what's called the Lightning network. Um, yeah, and my goal with this is not to uh, go into the real specifics, but just to give an idea of how these things are working, so that you can, if you can look at this more closely and read the Lightning white paper and so on. So yeah, that's Lightning aspect of things. Um, and this lightning work on lightning is happening really fast, and there's a lot of research. Most of the core Bitcoin developers are, I feel, there's some interesting things happening in the Bitcoin core protocol as well, that keeps on happening. But many of the research work in Bitcoin specifically is now happening in lightning. So definitely have a look at Lightning, and what Lightning Labs is the company, what they are doing, and try to run a Lightning node. It's going to be really a learning experience, but this is Lightning. Um, so yeah, Lightning aspect of things. Now let's move on to DeFi, which is decentralized finance. Um, yeah, and for this I'll refer this website called DeFi Prime. So for DeFi, my plan is to walk you through some interesting projects in DeFi and explain what's happening, what are various research areas, and what various teams are building. Um, so what the whole ecosystem of DeFi actually started because of DAI, this DAI, which I had shown in the previous presentation as well. And DAI was built by the Maker team. So Maker is this project. Um, it's a DAO, 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 a decentralized autonomous organization, and it's quite interesting what the Maker team has built, and it's so Maker system has two coins. One is called Maker coin, and one is DAI. The value of one DAI is always equal to $1, but the value of Maker fluctuates, right? So if we look at Maker, the value of Maker coin is now around $350, and the overall market cap is 335 million. And if you look at, like, say, the DAI value, it's around $1. $1. So the value of this always stays $1. Um, and how they achieve that, that's a very interesting mechanism. I in fact had made a video on my YouTube channel explaining Maker's system. You can look at that a bit more. But what essentially DeFi plans to do is, so the hitting a home run, right? The goal is to get rid of banks, and or at least create not get rid of them, maybe create a alternate finance system that competes with these uh, with the in which you can interest. You earn interest if you deposit cryptocurrency. And how that works is really interesting. And beyond the scope of this video, definitely, I would say you can. My goal is just to give you an overview on this. So, Compound is a very interesting project that most of the DeFi products they use Compound. You can see there's on the screen flashing like say on USDC, there's 0.75 interest, and on some other coins, it's this much interest. So the goal here with DeFi is to have these sort of mechanisms in which people actually have they can see a viable alternative to the current financial system. So, like say, if you are earning money in a stable coin like DAI or USDC or all these stable coins, you don't feel like okay, I need to deposit this fund in a bank because I'll earn an interest there, right? So the goal here is to have you deposit your funds on one of these DeFi products so that you can earn an interest here as well. And this is all decentralized. How the architecture works, maybe we can answer in a question or so, but yeah, it's beyond the scope of this call. And there are some interesting products in DeFi like this. This is Uniswap, which is a decentralized exchange in which you can exchange Ether, the Ether, right? Like say, um, let's look at DAI stablecoin. So if I say I have one Ether, for one Ether, I'm currently getting around 200 to use all these products. You don't even need to use a bank, and you don't even need to use a private key. You don't need to use a exchange, a centralized exchange. These trades happen in a decentralized manner in which you are holding on to your private key. And this is essentially Uniswap is a smart contract that is running on the blockchain, on the Ethereum blockchain, and that smart contract actually does these trades. So it's all decentralized. No one has the power to stop your trade. No one has the power to, you know, get themselves a better price, an unfair price. It's all decentralized. It's all run on smart contracts. Even all these Maker, Compound, these are all basically all these protocols are smart contracts running on Ethereum blockchain. Uh, so it's everything is decentralized here. And another interesting project which I find is Argent. Argent uses Ethereum smart contracts uh, to basically do this do fund recovery. So what essentially you can do is in a smart contract you can add some addresses as uh, as your backup addresses, right? Like say if you say if your funds are stored in a smart contract, which you can send your ether to a smart contract, and that smart contract would be owned by your private key. And say if you lose your private key, right? Then what would you do? You don't have any option. You lose your funds. But using Argent, they have their own smart contract. Even if you lose your private key, say I have five other private keys and that I have distributed among my friends and family, I would tell, say, my mom who had one key, my sister, or say my friend, three people out of the five people that I selected, I'll send a transaction smart contract to transfer my funds from this smart contract to another address that I own. And if they do that, this percentage depends on which protocol you are using, which product you are using. I've seen it to go up to 7% and stuff like that as well. But here it's 2% on Argent. So that's for the DeFi products we have. And in general, you can look at go to DeFiPrime.com and look at various projects that people are working on. DeFi is mostly on Ethereum. I would say all 100% on Ethereum, but to be honest, people are most of these projects are in fact smart contracts running on the Ethereum blockchain. So if you're interested in DeFi and if you're interested in Ethereum and smart contract development, I would highly recommend to look at what these projects are working on. Look at Compound, look at Maker. Yeah, look, there are a couple of other interesting projects like there's a couple of other interesting DeFi protocol. Uniswap, look at Uniswap, which is this decentralized exchange. Um, yeah. Okay, so that's the DeFi part. Um, and in fact, the value, if you look at like DeFi loans, there are now almost $1 billion that are in DeFi, if I remember correctly. So it's definitely this is DeFi is something which has come up in the last year or so. So it's still early days, but the amount of interest and that has been generated in DeFi, it's quite high. And in fact, in India, I would say in Indian blockchain ecosystem isn't that great. I would say compared to our other technological ecosystems. But India's DeFi ecosystem is quite good. We have there are a couple of companies. We have Madding Network, that is one project working in the DeFi space in India. We have Instead App, which is again a global. These are all companies, global companies that are competing with everyone that are from India. We have Nuo Lending uh, is another one that is interesting. Interesting project from India that you can look at. And again, you can see, okay, these are basically just you can lend and borrow cryptocurrency. Um, yeah, you can check it out later maybe. But yeah, interesting stuff happening in the DeFi space. If anyone is interested to work on this, maybe do research work with a company or do an internship or uh, try to get a job, just let me know. I'm connected with most of the founders of these projects, and I'll be happy to refer anyone. Um, yeah, so that's the DeFi part, and let's see. The third one is privacy. So in the next part we had Monero, which is a privacy coin, and Monero, in fact, is built on an algorithm called it's a fork, uses a fork of CryptoNate algorithm, and it's quite technical how and it involves a lot of cryptography on how Monero achieves its privacy. And in Monero, essentially, you can you know the which person is Dr. Hasirata, yeah. Okay. Hello. Is my voice fine now? voice fine?
Yeah, it's clear, Arnav. You can go ahead. Sometimes there is a network problem, I think, with the participants as well as with us sometimes.
Okay. Yeah. Uh, which is quite interesting. And yeah, it's Monero is really, if you are into cryptography uh, and you're interested in the privacy aspect of things, I highly recommend Monero to look at Monero. And there's another one recently which has come out is Beam and Grin. So I had a chance to interview Beam's founder on my YouTube channel as well. So maybe you can check that interview if you're interested. But Beam is these work on a technology called Mimblewimble, uh, and this Mimblewimble implementation has various advantages. Apart from privacy as well, it reduces the size of the blockchain, um, which is really beneficial. Like if say to a 200 GB size to 20 GB, then that means that more people can join the network. Right? So uh, Mimble is quite interesting, and in fact, Beam I think is these are now top cryptocurrencies within top 100 or so market cap. Yeah, top 150 is the market rank of Beam, and Grin is the cryptocurrency which is for the 151. They are in fact quite near each other, and people are using them. But for privacy, Monero is the leading one. Um, and if you want, this is one article which I read some time back that explained Ring CT, CoinJoin, and ZK Snarks really well, and for Mimblewimble as well. Oh, okay. Maybe I'll find a new. For Mimblewimble, I'll as well. There are a couple of interesting links you can look at. So yeah, that's it for the privacy aspect of things. And if you're interested, just let me know. There's in Bitcoin specifically, there's this concept of CoinJoin. So Wasabi wallet is a desktop wallet that usually does CoinJoin. It's a CoinJoin implementation, and essentially what it does, it mixes transactions, right? So say if it's a mixer, right? So if say 10 people, and it uses an interesting algorithm, but essentially it requires a lot of people to send transactions and then mixes those transactions and sends new, like say if I had one Bitcoin and I wanted to, uh, get remove my traceability of Bitcoin. Like if everyone can see the traceability of Bitcoin from, from its origination to its current state. But you can use this mixing the coin join or uh, what Wasabi wallet provides, and you can in fact wash your bitcoins in a way. You can remove the traceability of your bitcoin. So what eventually would end up happening is that's like say if I had an address in which I had one bitcoin, maybe three addresses or four addresses in which I get say point 0.3, point 0.1, and point 0.6 on point 0.1 or some combination of these bitcoins, and it sort of you can't predict that these coins belong to this address or belongs to that person. So but again this is people are using Wasabi wallet to wash their bitcoins in a way, but there are certain limitations to it, and it's still, I wouldn't say it's as secure, it's as private as Monero, because Monero provides on-chain privacy, which is really valuable. And for scalability in general, for another research topic is scalability, right? Blockchain scalability. For that, there is sharding. And I'll just explain sharding very briefly. So in sharding, what happens is you are essentially, as most of you are from computer science background, so you might be knowing about database sharding, right? So it's similar to that. There's sharding mostly in blockchain. One is transaction sharding and one is state sharding. So Zilliqa is one project that's a blockchain that's a sharded blockchain, and essentially what you're doing is you are dividing the blockchain network into various shards. So say you had in total 10,000 nodes. So what you'll have is you divide the network into 10 shards. You'll get say 1,000 nodes in each shard, and each of those shards is going to process transactions in parallel. So if say initially 1,000 transactions were getting processed, now 10,000 transactions would get processed. Um, and so that's what sharding is essentially. You're dividing the network, and the one issue is like, okay, if say you have very few nodes in the network, then sharding can lead to it reduces the security of the network in a way that it's easier to dominate one chain. Then like it's if the computation power is divided into 10 parts, then for one particular to uh, you know 51% attack malpractices there. But there are certain design decisions that you can make. Like Zilliqa, what it does is they have this initial sharding of a sharded architecture, and they have another a DS committee that they said, and that sort of set of nodes govern checks in a way that are all the shards working correctly, or maybe there might be a chance of a 51% attack or something like that. um, so yeah, sharding is an interesting concept, but sharding definitely requires to have a certain amount of nodes. You need to have lots of nodes to ensure that security remains in sharding. And even ETH 2.0, which is basically Ethereum's newer version that's coming out, they are also using sharding. So Zilliqa had sharding from the starting, but Ethereum uh, didn't. They were just doing normal one chain system, but they are also moving to a sharded based chain with the launch of ETH 2.0. So that's basically sharding. And again, it's a very technical. Can look we Plasma. Plasma is specifically designed for Ethereum. Plasma is it's basically like Lightning to an extent, but it's all happening on a smart contract. So we have this say a Plasma chain sort of that is running. That's essentially a smart contract that is deployed on the Ethereum blockchain, and that its own network within that contract. And Matic Network is one project that's from India, and that's a Plasma chain. Um, so you can look at that as well. Although recently there has been work on a thing called optimistic rollups. So most of the Ethereum's Plasma team has now shifted to this optimistic rollups. So but still, Plasma is an active area of research for scalability of Ethereum. And you have to think that achieving scalability is not one, there's not one way to achieve scalability. You can achieve scalability from multiple things. You can have layer zero, layer one scalability, like say using sharding. You can have layer two scalability as well, using Lightning Network or various payment channels and stuff like that. And say you get a scalability of 100x from sharding, scalability of 1000x from a Lightning Network. So the overall scalability would be 100,000, right? So you need to have most of the teams are trying for trying to achieve scalability through various ways, not focus on one thing, but have multiple uh, targeting scalability from multiple angles to increase the overall uh, scalability, so as to speak. And I covered about payment channels and Lightning Network that's specific to Bitcoin, uh, and we also had state channels. State channels is so payment channels is basically payments and stuff. But like say if you have a dApp, you have Ethereum, right? In Ethereum, you're not only sending payments to one from one person to another. you are interacting with smart contracts. You are, say, maybe using a social media, a DAB, a decentralized social media network. That's essentially a smart contract. For that, you are not only making payment transactions, you are making smart contract calls and doing smart contract transactions. So for that, you need to have state channels, and state channels, there's this company called L4 in Ethereum that was working, but I would this state channel is quite complex because payment channel is quite focused on payments, and the attack vector, the area of attack that you have to think on payment channels is very less. On state channels, that increases quite a lot. Um, but yeah, people are still working on it, although not as much as, say, Lightning Network. But still, there are teams researching on state channels, so you can look at that. Um, and another scalability approach is having a different consensus algorithm altogether, right? So we have proof of work, that is the consensus algorithm, but many teams are now, Ethereum is shifting to a proof of stake type system, or some teams are exploring other blockchain types, other consensus algorithm. Like there's this recent Sonana, they have a proof of history uh, algorithm that's slightly different. Then there are even DAGs, decentralized acyclic graphs. There's blockchain as such, uh, but they have this DAG, the acyclic graph, that is essentially the uh, that's how the new that's how the consensus looks like. And even IOTA is one example of DAG. I can even show you uh, an image of this decentralized acyclic graph to give a better example. So yeah, this is how a DAG looks like basically. This is a blockchain. It's a straight line system, and this is a DAG. And in an IOTA, I think it was um, for each node had to do one transaction, or for each two nodes you had to do a transaction or something like that. I don't exactly remember. But again, DAG isn't. I won't say it isn't that popular in terms of not many developers working, and there are a lot of issues with them. Like IOTA is not. They are popular, but no one actually, no developer is building on IOTA, or not. Most people just trade IOTA. They are not using IOTA as such. Um, but yeah, proof of stake, most of the teams are moving towards that. Bitcoin will always be proof of work. Bitcoin has no plans to move to a proof of stake. Bitcoin's community is not thinking of moving towards proof of stake, but for sharding and for various other systems, you need to have a proof of stake system. Um, you have to need to have some slashing conditions in which and stuff like that. For that, you need to take stake from as as the collateral in a way. So you, for that, you need to move to a proof of stake system. But yeah, it's not necessarily. Um, and so yeah, that's some areas I would say. So we covered Lightning Network, we covered DeFi, we covered privacy, and we covered scalability approaches. So these are, I would say, the cryptocurrency or research is taking place, and you can look at some other areas might be wallet development, like some interesting, like I mentioned, Wasabi wallets that working on coin mixing and stuff like that. um, but in general, wallets is an interesting area as well, although it's quite crowded. And apart from this, yeah, this covers, I think, most of the research area in blockchain. Apart from this, there's some non-research, more user-focused research, like say improving user experience of blockchains. Um, that's not what mostly researchers do. That's most like engineers and designers work on that. But there's work required there to improve user experience of people interacting with blockchain. It should be quite simple. So there's this concept of blockchain names. So like say if you have to send a transaction to someone, you need to get their address, right? And addresses are not that readable, they are not that human friendly. So we have this concept of there's this company called Unstoppable Domains. So you can buy a domain, like say I have arnavora.crypto. So if I send someone arnavora.crypto, they enter that to the wallet, they'll automatically be able to generate my address from this arnavora.crypto. And that this is more easily shareable, right? Instead of address. So yeah, that's about it. And from apart from this, if you need to follow some people on, most of the crypto community is on Twitter. Uh, Everyone is almost all the companies are there. Most of the Bitcoin core developers and people involved with the mining exchanges. Everyone is on Twitter, and you can just follow. These are some of interesting people that I found that I follow on Twitter. And this is just one list. I follow like 300 people on Twitter. And yeah, if you are highly Mastering Bitcoin book, Programming Blockchain book. These are two good books. These mostly, I think, I'm not sure about Programming Blockchain, but Mastering Bitcoin, you can just if you can find it on GitHub. Uh, you can buy a physical copy as well. I have a physical copy made myself, but you can just look at the book on GitHub. It's available freely. Um, you can look at various chapters that are available in the book and just go through them. So and it's quite detailed. And what people say that blockchain and crypto are different and some stuff like that. I just like to reiterate that most of the in industry is because of the cryptocurrency industry, and blockchain without cryptocurrency is not, it's like veg biryani. It doesn't exist. And it's like yeah, people do work on hyperledger, the supply chain type solutions, or I some healthcare solution is like one example, but most of them just end up being POCs. They are just proof of concepts that some big organization uses, but not many of them actually get used by real people. And that's what I've seen. Maybe that might change. I'm not sure, but from what I've seen with my time in the industry, if you have to work in something meaningful and something that gets you, to highly recommend to stay on the cryptocurrency uh, side of things in a way. Maybe do some research around the topics that I mentioned: scalability, privacy, usability, um, stuff like that. But yeah, you can look at Hyperledger and these enterprise type permission chains, but you'll not find jobs and that much. You won't find actual usage there compared to the other industry. Uh, so yeah, that's about it. I highly you can check out MetaMask. This is a Chrome extension, and so this I have like couple of Ether. This is a test net for Ethereum. So Ethereum has couple of networks. So this main Ethereum account, right? I have 17 Ethers here. Go to send, press here. Say I do point. I'm sending point 0.1 Ether. And this is like the wallet. This provides me with this interface: slow, average, fast, stuff like that. So if I do say fast, I just need to confirm. Boom, it's gone. So transaction has now been sent to the blockchain. It's pending for the confirmation. But if I go to say I send to this account, um, the transaction is not confirmed yet. But So that's how it goes. It's quite simple for people who are like, okay, you can just test it out. It's just do it on your own. Highly recommended. So if you want to get some like testnet ether, just go search for Ethereum testnet faucet. So these are testnet coins, so they don't have any value. So what you can do is you can and so some community members they run these faucets, and if you like, say I copy my address. So I just copied my address. If I copy my address here, and they can just send you testnet ether. So they just sent me testnet ether. So you just need to download this MetaMask Chrome. Uh, just Google for MetaMask. That's the name, and you can start playing with it. So yeah, that's it from my end. I'll just hold on for some questions if you want.
Hello, sir. May I audible? Hello. Actually, there is a challenge that is privacy. But the Monero and all the things, they are take care of that privacy. So, which kind of privacy we can consider and we can consider as a research area?
Sorry, Monero, what did you say? I didn't get that.
Actually, Monero and other applications are already work on privacy preservation. So, how we can again may work in a privacy preservation? Can you focus on this
Yeah,
point?
sure, sure. So for okay, you need to think there's privacy on chain. So there's layer one privacy, right? So Monero is layer one privacy, in which you have privacy on the blockchain layer itself. Now Bitcoin doesn't have privacy layer. Everyone can see, okay, this address sent this much money to this address at which time. For Ethereum as well, you can do that. So, if so, an interesting research area would be, say, working on privacy in Bitcoin and Ethereum. So, in Ethereum, there's this project called Tornado Cash. You can look at that. Uh, Tornado.cash. They were working. They have a smart contract that basically does privacy in Ethereum. I don't remember the website, uh, but you can look at this. So and you need to remember that Monero is quite small, right? Like not many people use Monero. Most people use Bitcoin and Ethereum. So it's definitely value in researching on privacy in Bitcoin and Ethereum. Um, so yeah, Tornado
Exactly
Cash, have a
how
look
we
at
can
this.
means related to algorithm or means in particular which area we can work in a privacy.
Yeah, that's what I'm saying. So look at Bitcoin and Ethereum privacy. So have a look at Tornado Cash in Ethereum. Okay, what's their approach? You can. This is again not people use it, but it's not there yet. It's like it's still experimental. And if you can, you in Bitcoin have a look at Wasabi wallet. You just need to look at it. I can't give you like exactly. You need to spend some time yourself, but. Yeah, it's not you'll not be working on core privacy, because you can't make changes to the core blockchain after it's out. So you, yeah, so maybe you need to work on a wallet or a smart contract that does this privacy thing. Um, so yeah, I'll recommend to check out for Bitcoin. Have a look at Wasabi wallet. This is Wasabi, and have a look at CoinJoin, how coin joining works, and maybe if you can write an implementation for coin join, or if you can suggest a uh, new better way to achieve privacy than coin join. So it's like you can't go. You have to look at the existing solutions and the existing things that are out there, and then you submit something of your own. That's how you should do it.
Thank you, sir.
Yeah. Oh, I thought, yeah. So I'll just type it out. So Wasabi wallet and Tornado. Have a look at these ones. I'm just writing them on chat.